Let's continue with division of physical quantities. How to solve divisions. Let's start solving in the way that we have done. Like one example. Now it's going to be important to pay attention for division that we have one numerator that has to be more simple and one denominator that has to be more simple before we start to make the division for itself. So let's try with this. 591 million of nanoseconds per millimeter dividing 0.00054 millimeters per centiseconds. Be very careful. Here your eyes are going to try to trick you, but remember we have a sandwich. We are going to talk about later. Immediately you start to see divisions, thinking sandwich. Step 0, breathe, relax. Step number 1, try to simplify, in this case, the numerator, or every single term that exists in the numerator, and every single term that exists in the denominator. Many zeros we can try to transform to scientific notation. Remember to use the inverse ruler of powers of 10 to know what value. So if you start to move your decimal point that is hidden here in 0, in that direction is going to be positive. So 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be times 10 to the 8th power. Now, identify any possible prefix that is there. Nano, it has a prefix, and milli is another prefix. So times 10 to the negative 9 for sec for nano, and milli has times 10 to the negative 3 for milli. Do the same, try to simplify for the denominator. We have 5.4 times 10. In that direction, my powers are going to be negative, so minus 1, minus 2, minus 3, minus 4. And identify the power of 10 associated to any prefix. So we have milli times 10 to the negative 3 meters, and centi times 10 to the negative 2 seconds. Okay, let's see. From here we can start to apply operation, and it's division, so let's focus a little bit more in the divisions. 5.91 times 10 to the 8, and we have division with the same base, we subtract, so times 10 to the negative 9 minus minus 3, and we have seconds per meter, my units. I hope you can see the minus that we have here. The minus 3 is this, but in division we subtract. Now for the denominator we have 5.4 times 10 to the negative 4 is the same. Times 10, I have minus 3 minus minus 2. I'm subtracting the power of the denominator. And my units, we have meters per second. Okay. Simplifying, in this case, let's solve this. 5.91 times 10 to the 8 times 10, negative times negative, positive, so it's minus 9 plus 3. We have seconds per meter. 5.4 times 10 to the negative 4 times 10 to the negative 3, negative times negative, positive. We have meters per second. I'm going to keep multiplication with the same base, so we can add the exponents. I'm going to simplify this one before I go forward. Minus 9 plus 3 minus 6. And I have seconds per meter, 5.4 times 10 to the negative 4 times 10 minus 3 plus 2 is minus 1. And I have in the denominator meters per second. Now I have multiplication with the same base, so we add the exponent. This is going to be 5.91 times 10, 8 plus minus 6 seconds per meter. 5.4 times 10 minus 4 plus minus 1. I have meters per second in the denominator. This is going to give me 5.91 times 10 positive times negative, negative. So 8 minus 6 is 2 seconds per meter. I already have very simple denominator. It's scientific notation and the basic unit in the international system. For the denominator, I'm going to have something similar. Minus 4, minus 1, minus 5. And I have in units meters per second. So we are ready, now that we have scientific notation and the most basic units in international system, scientific notation and the most basic unit, to make the division. So 5.91 divided 5.4, powers with the same base, division, and a division of 4/10, that is sandwich. I'm going to continue here. So 5.91 divided 5.4 is going to give me 1 point something. I'm going to start to round here, approximately 1.094. Now, division with the same base, as we already did before, we subtract the power of the denominator, times 10 to minus 5. And we have a division with 4 terms. Apply sandwich. We have seconds times seconds to be the breadth at the top, and meters times meters. Negative times negative, positive. And we have multiplication with the same base, we add the exponent. 1 is hidden here, so it's 1 plus 1. The same for the denominator, 1 plus 1. If you thought that we were going to cancel here, your eyes were tricking you. So for this reason, it's very important to apply sandwich. Plus 5, 7, and we have seconds square per meters square. We can keep this expression like that. Usually it's very, very common. Let's try to solve another example. Let's try what happens if we try to increase more our terms. Something that looks really big but is not, like this. So we have 0.0000000000071 nanometers per second. No, I wasn't going to use that one, but okay, it doesn't matter. We already simplified that. Let's try with something else. 0.000000321 kilometer per Kelvin divided 6.3 times 10 to the 9 meters to the minus 1 and something like 0.000000988 centiseconds square. And let's try to use this one to the third power. It looks really ugly, but remember we have step 0. Breathe, relax, and number 1, simplify. Numbers with a lot of zeros, we try to shrink using the most simple scientific notation. Let's see, this is going to be 7.1. Now, in that direction, the inverse ruler is going to tell me that it's going to get negative powers. Minus 3, minus 6, minus 9, 10, 11.